Hey everybody, this is Dr. Duncan, and this is BI 101 Explorations in Biology. And today we're going to talk about human population growth and biodiversity, mostly with a focus on population growth. This is one of the key ecological topics that we're going to cover this term, population growth. And instead of studying population growth of, say, fruit flies or fish or something like that, we're going to focus on us because this has a lot of implications about our lives and what our future is going to be like. And so for these reasons, it's a lot more interesting than talking about population growth for other species. Okay, before we get started, just a reminder that you should be taking notes during this video lecture. Write things out in your own words and then integrate your notes from this lecture into your own study guide. That is the very best way to prepare for this course and to study for this course. So see notes on Moodle about tips on how to do that. Okay, let's get started. You'll find various lists of the challenges to biodiversity on the planet as a result of human activity, and I like to go with this one, which is a little bit antiquated, but it's the HIPPO model. It lists there's 5 different traditional threats to biodiversity, and the letters of which spell out the word HIPPO. There's habitat loss and degradation, invasive species, population growth, that's human population growth, and pollution, and then overharvesting of species. And we'll be talking about all of these during this semester, but today we're going to focus on population growth. I also want to point out that now, after the HIPPO model was sort of arose, back last century, we now add climate change to the list. So I don't know how to spell a word with HIPPO, with HIPPO and a C, but if you guys come up with something, let me know, because that would be really handy. To put this in context, in terms of biodiversity, these impacts we humans are having on the planet and on each other, these 6 impacts, they are certainly affecting other species as well. And I mentioned this in a previous class that just 2019, a UN report came out explaining the degradation of resources on the planet, natural resources on the planet, especially ecosystems, and the impacts that's having on humanity, as well as the impacts it's having on biodiversity. And one of the predictions there, and the one that actually caught the most attention by the press, was that we're looking at losing about 1 million species by the end of this century if we keep living the way that we're living. So that's about 1/10 of the world's species by the way that they were accounting for species. So let's dig into population growth and understand why human population growth is on this list. And it's much more complicated than I think anybody probably realizes until you dig into these issues. To begin, what we're going to do is we're going to look up what the number of people being born per minute on the planet is. So let's get started with that. Okay, so this is a website that compiles data on the world's population, and you'll see that the world's current population as of this very moment is about 7.8 billion. Let me see if I can capture that. No, I'm failing. Let me pause and rewind here. Okay, so I got things figured out now. Sorry for that. This is what this is looking at is this is not actually people that are in hospitals clicking in every time a baby pops out. What we're looking at here is this is based on mathematical models, based on the census data that countries report. And so they build that into these widgets that keep running the numbers higher. And so we see things like current world population size, births this year, number of births today since midnight, number of deaths this year, deaths today, et cetera, et cetera. And there's tons more data here. If you like to wonk out with data, there is all sorts of cool stuff here. You can track down the sources too to make sure that what you're getting is legit. This population data is legit. I've been using this for years, and so it's solid. Okay, so let's go back to our damn it. Let's go back to our slide here, and what I'm going to type in is the time, and it is 6:02 a.m. Yeah, I had some insomnia issues today, and the population was 7,807 537 170. Okay, that is 7.8 billion people on the planet right about now. Okay, and what we're going to do is check in later to see what that population size is a little bit later during this presentation. So we're going to leave that here for now. Okay, so let's turn to the question, why is population growth a problem? The short answer is that it's because not so much of the numbers, but because of the unsustainable way that we live on the planet. We live in ways that are degrading and destroying the ecosystems that keep us alive. We've already talked about this a bit. Even though many of us sort of live in houses and apartments and dorms and things like that, it doesn't feel like we're connected to nature. That's because other people are doing that work for us in harvesting resources from nature and bringing them to us that we buy. So that's how our economy is working. So that's the problem with our unsustainable use of these resources, and this is driven in part by population growth, as we will see. Now, I want to be really clear about some issues about population growth arguments, because this has often been used by people promoting white supremacy, genocide, everything. Population growth gets into some really dicey political and social issues. So you have to be really careful about who is saying what about population growth. It's been used as a disguised way to talk about how to limit the growth of populations of people of color, and that's of course blatantly a problem, blatantly racist. But sometimes the modes of thinking about population growth slip into the mindsets of folks that don't realize that they're necessarily being racist or genocidal to talk about controls on population growth. There's definitely a problem of population growth, but it's not so much about the growth of populations in developing countries. It is about that, but it's also about the overconsumption of resources in developed countries. And of course, developing countries tend to be people of color, and because of colonialism, imperialism, and all that, the developed countries, not exclusively, but the developed countries tend to not be people of color. So you have to be really careful about of how these statistics are framed. You'll have a much better idea of all this by the time we're done with this video lecture. Okay, I want to point out to start with a term that you're probably not familiar with. Some of you might be. It's called Earth Overshoot Day. And this is a way of showing how we use the resources on the planet in an unsustainable way. So each year the planet generates resources for us. Fresh water is cleaned and recycled. Plants are growing, crops are growing, these fish populations are growing, these sorts of things. Okay, so these are the natural resources that we use. If we were living in balance with the planet, the amount of resources we would use in a year would be equal to or less than the amount of resources that the planet produces in a year. it's kind of like you can think about living with your income. If your income is $50,000 a year, then you don't want to spend more than $50,000 a year. Otherwise, you're going into debt. Well, unfortunately, that's what we humans have been doing for quite some time, is going into debt. And each year, in general, each year over these past few decades, we have been using all the resources that the Earth produces within a year at an earlier and earlier date. And that's what you're seeing here on this graph. So back in 1970, when I was just a little baby in diapers, um, we would use up the Earth's resources that are produced in a year by the date December 29. So that's just days before the end of the year. So that's really good. We would be in a great place if we were anything close to like that right now. More recently, the date has been in around August 1st or so. Okay, that means that by the time we reach August 1st, we have in recent years been we've already used up all the resources that Earth produces in a year. Okay, and this is a problem for many reasons. I kind of list some of these off to the right here. Agricultural land is being overworked, fisheries are getting overexploited, forests are being cleared, et cetera, et cetera. Lots of problems there. Okay. This year, 2020, is a little bit different because of the coronavirus, because a lot of people have lost their jobs and their income. The economy has slowed down. People are consuming fewer resources. So Earth Overshoot Day actually occurred a couple of weeks later, August 22nd. And no, this is not good news for the environment or the planet or people, because this delay of using up our annual budget of resources is because of a lot of at the cost of a lot of human suffering and misery. This is not the way. This is not the path forward to living sustainably on the planet, unfortunately. So, but this year is an anomaly. Okay, let's get into issues about how populations grow. And I want to point out here that what I'm going to be teaching you about human population growth is also the same for other species. So in other words, this is my way of teaching you about population growth for all species, just that we're focusing on humans. Okay. So to begin with, this is the history of human population growth. And you see on the y-axis here, this is global human population in billions with a B. And on the x-axis here, we've got a timeline. Here we are at the far right, where we are with the current time. And this is going back about 10,000 years ago or so. Okay. All right. So for most of humanity's history in the last few thousand years, populations very gradually were increasing. They were increasing as they were developing agriculture, and more people were living more healthy lives, longer lives, having more children, and that sort of thing. It was up and down regionally and so forth, but gradually there was an increase. We see a divot in that increase here. This was when the bubonic plague spread around the earth. It wasn't just in Europe, it spread through Asia and other parts of the world as well. So it hit different places of the world at different times and stuff. But it basically, over this time period, knocked out about a third of humanity. Pretty brutal times for sure. And then right about here, right about in the late 1700s and the 1800s, we began industrial growth. The Industrial Revolution began. And people were able to do a lot more work with much less effort because we were using machines powered by steam, and the steam we generated by burning fuel. At first, we started burning wood as fuel, but then we discovered coal, and we started mining coal and burning coal to generate that power. And that has essentially led to this very rapid growth in human population. COVID, that you see here. And this is equivalent to, especially in this time span up until very recently, equivalent to what's called exponential growth, which we'll talk about in just the next slide or so. But anyway, this is human population growth, what it's looked like over time for the whole planet. Okay. Now here's a graph just showing like exponential growth. Here you have time on the x-axis, here you have numbers. Exponential growth is this very rapid, steeply rising rate of growth. It just keeps going on and on and on and on and on. In terms of populations, this is representing populations growing at their absolute maximal rate. That would be like if every female in the population is having as many offspring as she can, this is what would happen to a population. In nature, this only occurs in rare situations where a population has no limits on the resources that they have available. That only happens for brief amounts of time because resources are always limited in the environment. That's true for other species, and that's also true for us humans. So we do see populations growing exponentially for short periods of time. However, that usually doesn't last very long. And instead, what we tend to see is what's called logistic growth. In logistic growth, and this is of course a mathematical term, logistic growth. In logistic growth, what we see is that populations eventually begin to slow down their rate of growth because of resource availability declining per capita. Per capita meaning per head, meaning per person or per bat or fish or plant, whatever it is you're talking about here. Okay. And what we'll see with a logistic growth curve is that we're going to see that population growth, and I'm going to show you this curve in a minute, population growth is a function of available resources here, okay? And a key term is carrying capacity, which is the maximum size of a population that can be supported by the available resources in the environment. So I'm tacking on in the environment there since it's implied and not stated explicitly on the slide, okay? So carrying capacity is the maximum number of individuals that can be sustained in the environment for that population. So here's a graph that illustrates both exponential growth in red and logistic growth in blue. And we're going to focus on logistic growth, of course, here. Down on the x-axis, we're measuring time in terms of number of generations. It's just a proxy for time. This is more tying the timeline to reproduction, number of generations. And then on the y-axis, we're looking at population size. And this dotted line here, this represents the carrying capacity. So for whatever species this is, I don't know, penguins, oak trees, whatever you want to think about. For this particular environment, it can only sustain just a little bit shy of 1,000 individuals, okay? And so what we see is, well, let me unpack that a little bit. That means that there's only enough resources here in this environment to sustain, we'll say, 1,000 individuals for long periods of time. And so what we see with logistic growth mathematically is that blue line, we have what is very close to exponential growth early on in the phase of population growth. But then after a few generations, the growth rate starts to slow down and the population winds up plateauing up here right at the carrying capacity. These lines don't overlap. They should if they were drawn correctly. So just imagine that those lines overlap and that the blue line actually intersects with the dotted line there, okay? That would represent population growth in a realistic situation where there's a limit to resources in the environment. Okay. Population growth is also referred to as S-shaped growth or sigmoidal growth. You might have seen that in some of your classes if you guys have taken social science classes and so forth. Okay, moving on here. All right, so here's a question for you. During logistic growth, what happens to the population growth rate as the population size approaches carrying capacity? Does it increase? Does it stay the same? Or does it decrease? Okay, so we're talking about growth rate, which is the number of new individuals born over time. What happens to that rate? Go ahead and pause this video, spend a moment thinking about it, and then resume the video when you're ready to talk about it, or ready to hear me talk about it. Okay, presumably you've thought about the answer, and the correct answer here is that it decreases. Okay, so looking down at the graph, what we see here in the early phase of population growth, I'm following the blue line here, the logistic growth, is that we have a rapidly increasing rate of population growth. That means that as the generations go on, up until about generation 7 or so, the rate of population growth is increasing. Each year, more and more individuals are being born than in the past. But starting right about here, population growth rate starts slowing down. And the reason for that in the population context is that there's fewer resources available per person. If you imagine like a metaphor with like a pie, slicing up the pie, and the pie representing the resources available for the population, the more people that you have, or the more penguins or whatever that are eating that pie, the fewer or the less pie each animal, each human gets to have. And so that puts a limit on how many offspring in the human context, and the offspring that women can have, because of limits on resource availability, food, and so forth. Okay, so the correct answer here is that it would be decreasing as population growth approaches the carrying capacity. All right, moving on here. So what are the projections for human population growth this century? This is pretty important stuff. You guys were born roughly around the year 2000. You're going to live out to see most of this century. How is all this going to be affecting you? Well, it's going to be affecting you a lot. I just pulled these data. These are the most recent data issued by the United Nations. And what we see here on the x-axis is time, and with historical context going back to 1950 and then projected out to the year 2100. Here we're looking at total population on the y-axis in billions. And what we see here is the blue line representing actual population growth up to right about here, or I guess right about here, where we then are using models to project population growth, because obviously the year 2020 is right about here. So we have to use models to project that growth. And of course, with any model that's done well, you get like a high range and a low range, and what is the most common result of the model. And that's what you see here with the dark blue line. But that range varies from all the way up here at like roughly 12.5 billion to roughly 9.5 billion by the year 2100. But most estimates, these numbers, and the one that we'll use for this class, is that by the year 2100, we're looking at about 10.9 billion people on the planet. For the year 2050, which is 30 years from now, which I hope to be alive, I would be 80 then. You guys would be my age, 50. Then by the time you're my age, there should be around 9.75 billion people on the planet, according to these United Nations models, which has generally been recognized as the best models of human population growth. But we're going to look at some new models that came out just this summer of 2020 at the very end of this lecture, which shows something else. So a little cliffhanger there. We'll come back to that in a few minutes. Okay, moving on here. This is a map. It's a little bit outdated, but I can't find a new version of this. Well, honestly, I haven't looked that hard, but this pretty much illustrates like what our future looks like, even though it's a little bit out of date. This is illustrating where population growth is happening. So the original map would show the countries with the right amount of geography associated with each country. Obviously, this map is distorted, and each country's size is distorted to represent whether the country's population is growing or shrinking by the year 2050. Okay, so you see, for example, Mexico in dark blue here. Mexico pretty much looks like Mexico does on a normal map. Its population is relatively stable. There's a little bit of growth, but mostly it's stable. The US is going to grow a little bit, but not a lot by the year 2050. Um, in contrast, look at India. India is still growing and growing rapidly and will grow a lot by the year 2050. China, even though its growth rate has slowed down, it is still growing, and so forth. So basically, this illustrates where population where population growth is happening in the world the most. And it probably doesn't come as a surprise that it's China, India, parts of sub-Saharan Africa, especially Nigeria, and we also see high growth in the U.S. and a few other countries. Okay, so that's sort of a look ahead at what will be happening over these next few decades. Okay, so given that most of the population growth is happening in developing countries like India and sub-Saharan Africa and China and so forth, is population growth in the US a problem? Well, I will argue here, as many others do, that it most definitely is. Okay, so here's a question for you. If take the average US citizen and imagine like the amount of resources they use in a year. It's the water that they drink and they use for, you know, bathing and watering their plants and washing their car and all that sort of water. And then all the water that is used for growing the crops that they eat or uh, uh, drinking by the livestock that they eat and that sort of thing. So that's all the water use. Imagine all the land that's used for agriculture to support the average U.S. citizen, and all the other resources. But land and water are the big ones there. Okay. How many planet Earths would it take to support 7 billion humans on the planet with the lifestyle of the average U.S. citizen? Okay, I know we're at 7.8 billion here, but just go with me here and we'll just use the 7 billion. So take a moment to just think about what that answer might look like. Okay, let's find out the answer to this. So it's definitely we need more than one planet, Earth. Um, as we look ahead here, then is it 2 planet Earths? No, we need more than that to sustain everybody at the level of the average U.S. citizen. What about 3 planet Earths? Nope, it's more than 3. It's actually, is it 4? Nope, it's more than 4. It's actually 5. To sustain just 7 billion people at the level of the average US citizen, we would need 5 planet Earths, which is obviously a ridiculous scenario because we only have one Earth, and we will never, even if we colonize Mars, be able to replicate what we have here on Earth, in terms of the resources and the food that we can produce and so forth. So this illustrates the problem that we're facing, that in developed countries like the US, and that is that we are not living sustainably. And so more about that right here. The US is only about 5% of the world population, but it uses 25% of the world's resources. Let that sink in for a moment. 95% of the world's population is looking over at the US saying, wait a minute, why do you guys get a quarter of the world pie? So this helps explain some of the international political challenges that our country faces when negotiating with other countries about issues such as resource use and these sorts of things. The US does not have a very efficient way of using its resources and so forth. And as a consequence, we're kind of hogging a lot relative to our numbers. And that has consequences. For example, the average US citizen uses the equivalent resources of 2 Japanese during their lifetimes. So if you're the average American, you're going to be using the same amount of resources in your life that 2 people in Japan use in their lives. Okay, and you can read down the list here all the way down to some of our poorest countries like Ethiopia, where the average U.S. citizen uses in their lifetime the same amount of resources used by 372 Ethiopians. So all of this to say that population growth in the US can be just as costly, if not more costly, to the Earth's environment than population growth in some of these countries that are growing rapidly, like India or China. And this gets back to that very early point about like population growth being an issue that gets into issues of racism and so forth. And that is that the problem about population growth is both in developing countries that are growing quickly as well as in developed countries because of the per capita resource use. There's plenty of problems to go around. No country is in is no country. Well, no, let's see. Let me see how to phrase this right. Everybody is part of the problem. That's really what I want to say. All countries are part of the problem, and that's why we need solutions that work for everyone. Okay, moving on here. So I introduced earlier this concept of carrying capacity, the limits on how many individuals in a population can be sustained by the environment. So what is the carrying capacity for humans on the planet? Perhaps you were already wondering about that. Well, we don't know. um, there's scientists from different fields have estimated this in different ways and come up with different answers. So it's an elusive answer to that question. We may never know, actually. Some conservative estimates say that human population growth that our carrying capacity is around 7 billion people. So if it's around 7 or even 8 billion people, we will, if we're not already over our carrying capacity, we will soon be over our capacity. More liberal estimates say that it's up around 10, and very liberal estimates say it's around 14 billion people on the planet. Okay, it kind of all depends. The reason that there's so much uncertainty, it all depends on how we choose to live on the planet. We are nowhere on Earth are we living very efficiently, making good use of our resources. We can all live, all 7.8 billion of us, and then throw in a couple extra billion for good measure. We can all live very comfortably on the planet, much like you and I live today. If you and I represent sort of the average American, everybody can live a lifestyle of comfort and prosperity like that, but only if we're careful about how we use our resources. So developing a sustainable economy is one of the, that's why that's one of the UN's, United Nations biggest goals, because we really need to get there to alleviate a lot of suffering and human misery on the planet, and to ensure that that humanity has a long and bright future on planet Earth. Okay. I kind of hit, I think, a lot of these points in the previous slide. Yeah, so on average, estimates are for our carrying capacity that it's around 10 billion or so, if you take the average of all that. But again, it's just speculation. We don't really know. All right, so we are at 7.8 billion people on the planet right now. We're looking at capping out at around 10.9 billion people on the planet by the year 2100. How are we going to support another 3 billion people on Earth when we're already dealing with a lot of environmental problems? This is a huge issue that we're already in the middle of dealing with this crisis, and the answer to this question will be shaping lives for people around the planet for the rest of this century, kind of in the background. And this is why there's so much focus on developing a sustainable economy, sustainable agriculture, et cetera, et cetera. How can we keep doing this without crashing and burning? Okay, so if you talk to ecologists like to take a holistic view of our situation and emphasize that there are some really hard limits on how much photosynthesis can be done on Earth. Limits based on how much land surface there is and how much plants can grow in different environments based on rainfall and temperature. And that photosynthesis, that's where all of our food comes from. Even if you only ate hamburger meat all day, every day, right? Well, those cows that you're eating are eating grass and grains. So everybody winds up ultimately eating plants and being dependent on photosynthesis. So if you look at photosynthesis on the planet, we're already capturing about 50% of the photosynthesis that happens on planet Earth. And we're capturing that as agriculture. And that's both row crops as well as ranching. So it sounds like, well, hey, we got 50% left, but that 50% that's left is really harsh environments that it's really hard for us to grow crops. And then some of it is actually where we have the last strongholds of biodiversity, like tropical forests, Amazonian tropical forests, for example. So we really don't want to be eating into the other 50%. Otherwise, we're going to have lots of problems. So here's a pie chart that sort of illustrates, and it's an older graph, but it's still mostly true, about like what resources, land resources, we still have on the planet to use for agriculture. And this is based on temperature and rainfall patterns and geology, the types of soils that are out there. And what we see in this pie graph is that there's about 51% of the planet is not conducive to generating food, either through ranching or through growing crops. Okay. If we look at what is currently in use, this says this would be 21% back when this graph was done. It's a little bit higher than that now. Okay, that we're using about, we'll say 20. We'll just ramp it up to like 25% of the planet is already in use for either agriculture, like growing corn and rice and grains and things like that, or it's grazed. Now, I want to illustrate here or explain here that on lands that are more arid, so they're drier, where grasses grow, that's where we tend to herd cows and other grazing animals, and then we eat them. So this wet part of the wedge over here on the right represents the more drier conditions on the planet where we can eke out some food, but we have to use other species to convert that plant growth into food that we can then eat, either like dairy or meat. So of all that land, we're using about 10% already, and then about 15% is these very dry lands that are not conducive to, say, growing corn or soybean and things like that. Okay. Over here on this part of the pie chart is where is either cropland that is in use or potential cropland. And this is lands that can actually grow row crops like rice and corn and all that kind of stuff. And we're using by now it's like about roughly half of that. Okay. So all of this to illustrate that there's not a lot left for us to put into use for generating food. We do have these arid lands here that's potential grazing land, but right now those are areas, that's some of the last strongholds of biodiversity. These are the places where you have, herds of zebra and elephants and all that kind of stuff. In Africa, and then similar things happening in South America. Okay, so you've got this, and in Asia, you've got potential grazing land out there. But if we convert it all, we're going to lose a lot of species, as well as a lot of other things that are important to us. Ditto with these lands that are potential cropland. Some of them are drier, and then some are tropical forest. Again, that's where biodiversity is surviving, the biodiversity that's left on the planet. So we really should try as much as possible to stay within this wedge here and not expand into those areas if we want to keep biodiversity around. Okay, so these are the stats that I pulled off the table here for you. If I ask questions about this on the exam or on a quiz, I will use these numbers, even though I said this wedge is now about 25%, just to keep it simple for you guys. I'll use these numbers on any quiz or exam. Okay, moving on. All right, so I want to have you pause for a moment and do a little bit of critical thinking on your own. I want you to answer the question, what do you think are the connections between human population growth and biodiversity? Okay, we've talked a little bit about this, but it's time for you to start being able to articulate it yourself. Pause the video, spend a couple minutes thinking about it, and then I'll share with you what I think should be some really strong answers to this question. Okay, I'll assume that you paused the video and you did some thinking. Let's compare answers. So this is what I would say are some of the strongest answers to this question. There's many different versions of this and other answers to this question, but this is what I think are most important and relevant to our conversation this morning. First of all, the more land we use for agriculture or ranching, the less there is for biodiversity. We talked about that just previously. But we don't just get food from ranching and row crops and agriculture. We also go out into out into the wilderness, into ecosystems, and harvest wild food. Mostly these days, it's done via fisheries. A fishery, of course, is referring to a species of fish or squid or crab or something like that we exploit for food. Okay, and the more that we harvest of wild food, the less biodiversity that there is. So, for example, we can harvest a lot of krill for the ways that we use krill, but then there's less krill for whales to feed on and so forth. And so the more wild food we harvest, the weaker our ecosystems become and the fewer ecosystem services we get from them. So obviously I'm taking from a humanities perspective, a selfish view on this, that it's all about the ecosystem services, and ignoring for the moment that, maybe other species have a right to be on this planet and not go extinct. We'll get to that in another class. Okay, moving on here. Okay, so here's a question that you might have heard over these last few months. If human population growth is a problem, are pandemics like COVID-19 good for us and good for the planet? Is this natural population control, and is this something that should be seen as good? I clipped this off the internet just this morning from last May. People are actually talking about this, and even before the pandemic, you would hear this being said. It's unfortunate to hear this because it represents a great deal of either malice towards other humans on the planet or just a lot of ignorance. So let's unpack this. First of all, this thinking is morally flawed, and scientifically it is also flawed. To begin with, it's morally wrong because if you look at the pandemic, the COVID pandemic, who's dying? It's people of color. Here in the U.S., it's predominantly Latinx and African Americans that are dying, and it's also it's poor everywhere. It's also white people that are poor as well. And so to argue that we should just let diseases sweep through the population and do a purge or something like that can be considered racist, if not genocidal, not to mention just really cruel. So there are some serious moral complications with making the argument that pandemics are good for natural population control. But scientifically, it's just wrong-headed. It just doesn't even make sense. Check out the math. Okay, so the number of humans born each year is about 140 million, that's with an M, 140 million children born each year, okay? How many people have died from COVID as of at the end of August 2020? We're looking at about 820,000 since March, okay? So that's 6 months. Double that and you're looking at 1.6 million during a year if we can continue at the current rate. If that's true, then it would take the Rona 88 years to cancel out 1 year of births on the planet. Okay, so the math doesn't even work here and doesn't even come close. Certainly other diseases are killing a lot more. Malaria, for example, is killing about 1 million people a year. So that would be less than what I'm projecting here for coronavirus if this continues until March. But the point is this, the big point of this is that if you're going to argue that we need disease outbreaks for population control, then you are arguing for unimaginable levels of human misery and suffering. And you're really kind of promoting a classist, if not a racist agenda, given the disproportionate impacts on this disease and other diseases on people of color in the world's poor. Okay, so one of the there's some other ways to look at population growth and to answer the question, should we let people die as natural population control? And I want you to watch this video by a guy named Hans Rosling. Unfortunately, he passed away about a year ago or so. Um, brilliant mind this man has, and exceptionally gifted at explaining the relationships about economics to our lives, including population growth. So I want you to watch this video and take notes. Of course, you'll have questions on the exam about this, maybe on your quiz about this, and then I'll resume the video lecture after that. So go ahead and pause, go to Moodle, find the link, watch the video, and then come back. Okay, welcome back. I assume you've watched the video. I hope you agree it's a pretty cool video. I love those graphics that he's designed. So after watching that video, you should be able to explain the relationship between fertility rates and economic development, and be able to explain what's been the history of human population growth in the last 70 years between developed and developing countries, and also be able to explain why war, disease, famine, etc. causes the continuation of high birth rates in developing countries. It's not a solution, it just prolongs the problem. Okay. Let's dig back into some of the mechanics of population growth, again with a focus on humans. So let's look at the fact that populations can rise and fall or remain stable. Population growth, or population change, I should say, is a function of the number of births plus immigrants coming into a population minus the number of deaths plus those that leave the population, or immigrants with an E. Okay, you can remember immigrants with an I, they're coming into the population, into with an I, immigrants with an I, and immigration leaving the population, like exiting with an E. I almost said X. I did say X. All right, so exiting the population, both immigration and exiting start with an E, so you can remember the difference between those words. Okay, so this population change is affected by several things. There's the crude birth rate, which is the number of births per 1,000 people. This is maybe not effects on populations. This is probably mislabeled. It's different ways of measuring population growth. Okay, so we got crude birth rate. We got the crude death rate, which is number of deaths per 1,000 individuals. We've got migrations. We've already talked about that. People coming in, people leaving. Okay, and this is also true for plant and animal populations as well, all of this. Births are measured by fertility rate, which is the number of children born to a woman during her lifetime, and that can be further broken down into what's called replacement level fertility rate, which is the average number of children needed for couples to replace themselves. It tends to be higher in developing countries unfortunately, because of high rates of death of children. Newborns, especially within their first year of life, high mortality rates of children is why couples in developing countries have to have a lot more children than in developed countries in order to replace themselves. It's not that people are thinking, honey, we need to replace ourselves, let's get busy. It's more, it has to do with cultural norms and choices about like how many children you want and these sorts of things. But from a demographic perspective, a population perspective, we can condense it all down to replacement level fertility rate. Okay, another and more common way to see fertility rate portrayed is total fertility rate, which is the average number of children born to a woman during her lifetime. Okay, this is all in your textbook, and it explains it there, and so you can come back to this in the textbook. Now, this is a graph showing time on the x-axis, up projected through 2050, and total fertility rate. That's children born per woman on the y-axis. And we've got both the entire world in blue here And we've got the red line are less developed countries, and green line is more developed countries. And what we see here, and this came out in Hans Rosling's video, is that total fertility rate is declining. It's declining in the developed countries, and it's also steeply declining in the less developed countries. And we're looking at converging these lines like later on this century, the second half of the century. So to break it down a little bit more, back around in the post-World War II era, up till around 1970 or so, in the less developed countries, women were having about 6 children during their lifetimes. Can you imagine? Maybe some of you came from large families, but I think most of us in the class, or most of your professors at the college and stuff, came from substantially smaller families. By the year 2000, that had dropped to around 3 children born per woman, and it's continued to drop since then. And this is really good news in terms of for developed countries as well as developing countries, because when there's fewer people, there's more resources per person. And so back when I lived for a year in Africa, I think I mentioned that on TikTok, maybe not, I can't remember. I lived for a year in Uganda in Africa, and at the time that I was there were these posters that you'd see like in public places the government would put out. It'd have a picture of like a family of like, I don't know, like 10 like parents and like 8 kids, and they're all like dressed in rags and looking pathetic. And then there'd be like a picture of a couple with like 2 kids or maybe 3 kids, and they'd be all like bright and shiny and well clothed and obviously well fed and that sort of thing. And then the slogan was a smaller family, happy life. And essentially it's true that in developing countries, those that have better economic means tend to have fewer children, and the reverse is also true. The fewer children that you have, the more resources you have for each child. There's a lot of complexity to all this we're going to be getting to in just these next few minutes, okay? We'll start with this by looking at what factors affect fertility rates. And here we're specifically talking about humans. Some of these transfer to other species, some of them don't, okay? I'm not going to read through this whole list here. You can pause and read through them yourself. This is all pulled from your textbook, so free study guide for you right here. I would ask you to consider, like, given what sort of size family were you born into? Are you an only child? Are you, one of 3 or 4? My wife's one of 4. I'm one of 2. What factors on this list affected your parents and their choices in how many children that they've had? Which ones might affect your choice if you choose to be a parent, or if you choose to not be a parent? Whether you're having children by birth or you're adopting, since not everybody wants to have children by birth or can have children by birth. So I would encourage you to think about this. But all this to say that there's a lot of factors that influence fertility rates in humans, in people. And so it gets into the social sciences very quickly. So this is like the border, like a not a blurry zone, but an integration of like social sciences and biological sciences here. Okay, this is a similar graph to the one before, same kind of timeline, but now we're looking at infant mortality rate. That's the number of deaths per 1,000 live births. So this is when women are giving birth and the child dies during childbirth or is stillborn or dies very soon thereafter. And infant mortality rates are declining, and this is really good news. It's on several levels. It's good news because, of course, this is a very traumatic thing to happen to anybody. To have a child growing inside of you for 10 months, and you're looking forward to greeting that child finally, and then you have this happen. It's tragic. So it's really good just for that reason alone that this is happening. But it's also good because this represents that standards of healthcare are improving around the world, and are improving very rapidly in less developed countries. And when standards of healthcare increase, women tend to have fewer children, and that's a good thing for human population growth issues. Okay, so that's why this is good news, very good news. I also want to take a pause here to say that these lines, like less developed countries and more developed countries, you can also apply that, say, within the United States and look at different socioeconomic strata. So the green line here would represent middle class and above in terms of economic class in the U.S. But if you look at lower socioeconomic strata, we see much higher rates of infant mortality. We see that really high in African American populations. And that's not just about economics either. There are other issues there as well that have to do with issues of like the this gets complicated fast, but it has to do with issues of like impacts of systemic racism on populations, and stress levels and how that affects uh, women in their ability to carry children to term and so forth. Um, anyway, so moving on. So, how does all of this affect the structure of populations? You maybe haven't thought this question to yourself, like who sits around thinking about population structure. So, let me get you thinking about population structure, and let's talk about how all this kind of comes together. So, these are population structure diagrams, also known as age pyramids. What we're looking at here are countries grouped by how rapidly their populations are changing, either expanding or contracting. Uh, each of these bars that go left and right represents an age group. Um, so this so these three red ones here represent the pre-reproductive changes. So we're looking at ages 0 through 5, 5 through 10, 5 and 10 to 15, for example. The next sets of years in chunks of 5 represent the prime reproduction years. So this would be, like 15 to 20, 20 to 25, and so forth. Okay, and then the blue bars represent later in life when people pretty much stop having children. Um, the width of the bars, left and right, in one of these pyramids illustrates like the proportion of a population that is in that age group. Okay, so for example, in a country like Guatemala, the children under the age of 5 represent the largest fraction of the population. Old people in this category up here, whatever that is, I haven't done the math, represent the smallest category. Okay, the smallest population for that age group. Okay, so what we see that in developing countries that have rapidly expanding populations, we tend to see a really wide base to the pyramid here, and you see a sort of a curvy slope to the sides here as it truncates up to the top. Okay, in countries that are expanding slowly, like the United States, we also see a pyramid shape to this, but the base is not as wide. So the difference here between one of these sets and the next is much slimmer compared to over here. 0 to 5, there's a big jump between that and age 5 to 10, for example, but not as much over here. These populations are growing slowly. And you can visualize that growth by imagining this bar right here in 5 years becoming that bar, and in 5 years becoming that bar. And because after the first few years of life, people tend to continue living, there's not as much mortality, that bar stays wide like that and just truncates, gets slimmer very slowly as it moves up. Okay. Some countries in the world are stable or near stable. Japan, Italy, and Greece are some of those countries. And then some countries are actually declining. And actually, Japan, Italy, and Greece are projected to get into this declining category if they haven't already. Russia, Bulgaria, Germany are a couple of examples here. Okay, so what we see here is that the width of these bars is is really narrow compared to, and getting narrower as the years go by. So these are declining populations. Okay. I want to make it clear that declining populations are not in some form of cultural decay. They're just adjusting to their economy. They're adjusting to their available resources. Transitioning to that new economy, that new level of resources, can be difficult when you've been relying on a lot of labor, and you now have a declining workforce size, and that's one of the issues that a lot of countries are going to be facing this century. Okay, so let's take a look at what kinds of factors are affecting growth rates. And I want to spend some time here on what's called the demographic transition model. Some of you might have seen this in a social science class before. So what we're looking at here on the x-axis is time, just sort of generic time. And then on the y-axis, we're looking at several different variables. We're looking at total population size, and we're looking also at birth rates and death rates. And this is birth and death rates per 1,000 individuals, okay? And what we see in this graph is that it's divided up into 4 different quadrants. There's the pre-industrial stage of a population, the transitional stage of a population, the industrial phase of a population, and the post-industrial phase. And what social scientists have seen as you look at different countries around the world as they've gone through different as they've gone through economic development is that they tend to go through this pattern here. And this is why Hans Rosling was able to show us that pattern where you had developing countries go from the lower right-hand side of that graph where women have high birth rates and it's relatively low economies to up to the top left where birth rates decline as economies develop. There's more wealth per person, okay? All right, so let me walk you through this a little bit. In the pre-industrial phase, so this is before agriculture and that sort of thing. So think hunter-gatherer fisher phase. Population tends to be relatively stable over time. Birth rates and death rates over time equal each other out. Some years are really good and you get more births than deaths. Other years are really bad and there might be like a drought or in some famine and that sort of thing, and you wind up having death rates higher than birth rates, but overall they sort of equal out. But as human populations began to domesticate animals, and as we started doing agriculture and then the development of medicine and so forth, death rates have declined. So this is in the transitional phase, transitioning to an industrial economy, okay? Where death rates tend to go down. Birth rates, on the other hand, tend to stay high for cultural reasons. You probably have heard this before. People that like come from large families like to say, I'm going to have lots of kids just like, I grew up in a big family. I want to have lots of kids too. That's not always the case, but it's often the case. It's cultural practices that are at play here. And so birth rates tend to stay high. But after a couple generations, birth rates start to decline. By the second or third generation in the transitional phase, women are starting to have fewer children. Death rates, meanwhile, have dropped down, but they sort of level out. There's only so far we've been able to push down death rates. We're still getting picked off by cancer and all sorts of other things, and so death rates kind of have stabilized over time. Now, if you look at death rates to birth rates, as long as this red line of birth rates is above the blue line of death rates, you're going to have population growth. And that's why we see this green line increasing during the transitional phase, okay? Because births are more than deaths. Population keeps growing. One of the problems that we've had for much of last century and still for some countries in this century is that countries are kind of stuck in this transitional phase here of growth. They're moving through this process very, very slowly because their economies are developing very, very slowly. And so birth rates are staying higher than death rates. And this is why countries like Nigeria are just absolutely exploding in terms of their populations. Okay. Um, Many countries of the world, not enough, but many countries of the world have moved on to an industrial phase. And in the industrial phase, birth rates decline even further and populations start to level out. You now have very few people doing agriculture and ranching, and more people are working in offices and factories, doing manufacturing, or in the service economy and stuff like that. So you've now got an industrial economy. For example, the US is an example of an industrial economy. Some countries have gone into a post industrial phase, and that is signaled by the point where the birth rates meet death rates or drop below death rates. And we saw that back a couple of slides here. These countries would be in this post industrial phase. Okay, so this is the demographic transition model. And the things that are affecting what happens here with birth rates and population growth have a lot to do with that list way back here. All these things are going on and changing as countries go from a pre-industrial to an industrial society. Okay, so this helps explain what we saw in Hans Rosling's video and vice versa. What he showed us there helps explain what we see here. Okay. All right, so let me quiz you on this. Hit the pause button and answer this question, and let's see what you come up with. Okay, so which point on the demographic transition model would this age pyramid represent? It would represent the transitional phase here, where populations are growing really rapidly. Birth rates are much higher than death rates, so you get each generation is a lot bigger than the previous one. Okay, here's another question. Which of these age structure diagrams could be an accurate portrayal of either the pre-industrial or the post-industrial stage of the demographic transition model? Go ahead and pause the video here and answer this yourself. Okay, let's see. I hope that you came up with the answer C, because this age structure, this age pyramid graph would illustrate what populations look like in the pre-industrial phase where births and deaths equal each other out, or in the post-industrial phase where births and deaths are equal to one another. Okay, moving on here. Oh, it's time to check our human population growth again. So I'm going to pause this video and then get this set up, and we'll come right back. Okay, so I got those stats up for us here. And about an hour later, world populations was estimated to be 7,807,546,997. And if you look at the delta there between those two numbers, that's a difference of 9,827 new people on Earth just within 1 hour, which I think is an impressive amount of fecundity for our planet, which also illustrates that we are still a long ways off from hitting our peak on population growth. Okay, so what, if anything, can be done about human population growth? Well, a lot, and there's a lot of good news here as well. One of the most important things, if not the most important thing, is ending poverty and raising standards of living. Birth rates tend to decline as economic prosperity increases. So as we help developing countries out of their transitional phase and into their industrial phase, that's good for the global economy, it's good for their economies, and it's good for all the people in their economies. Ending poverty is generally regarded as morally good by most folks, so it's not hard to rally people around that. Getting countries to devote resources to help developing countries is a much more complicated issue, of course, but there is, it's easier to rally people around, at least around the idea of ending poverty. And all this is better for the planet. It's good for biodiversity because ending poverty alleviates pressure on the environment because people are able to make better choices, more longer term, more careful choices about how they use the resources in their environment when they have economic security. When you don't have economic security, you are not so much worried about the long-term sustainability of your environment because you don't have the luxury of being able to worry about that. You're more worried about surviving day to day. So all this to say that when you protect people, when you help people, you're also helping the environment. Social issues are just as important as the environmental issues. Okay, sorry for that visual interruption with the slides. I'm recording this from my living room and people are coming and going from work and all that kind of thing. It gets a little complicated. Okay, so as I was just saying, ending poverty and raising standards of living is important as a solution for population growth as well as for the environment. Another way to think about the connection here is that environmental degradation affects the poor first and most intensely. And that's because they live, the world's poor are living in much closer to Earth. You know, they're getting their water from the environment, like these young girls are doing. They are, harvesting their food from the land. Some are harvesting wild foods, like from fisheries and forests and things like that. Getting their fuel wood for their cooking fires and stuff from forests. And so as the environment degrades, it affects the world's poor first and foremost. So again, when we improve standards of living through economic development and these kinds of programs, it's good for people and it's good for the environment. So protecting the environment is also protecting the people and vice versa. That's really the point of these two slides. You protect the people, you protect the environment. You protect the environment through doing all these sorts of things, and you're protecting people. Okay. Now, another reason why population fertility rates have been declining and population is going to stabilize probably this century has to do with what you see going on in this picture here. That in developing countries, women are being educated for the first time and entering the economy, as you see here with this woman in Uganda. We, as women, trend, like are getting schooled and going into economy. Many different things are happening. They have fewer children. They space their children out more, and the children have better lives because of the the family, the mother especially, has more resources for that child. Um, some women choose to then not have children. There's all these different reasons that when women are empowered through education and by integration into the economy, it's good for the overall economy, it's good for those women, and it's good for calming down birth rates. And that's why we're seeing a lot of developing nations now have moved to the point where their total fertility rate is approaching much lower numbers, or approaching around 2 or so, or sometimes even less. And that's all making good progress towards calming population. It doesn't address the problems of overconsumption in the developed countries, but it does help with the rapid population growth in the developing countries. A third thing that helps with population growth is promoting family planning. This should be pretty obvious that giving people, by people I mean men and women, giving them the tools to control whether or not they are having children or not is something that's really critical for empowering couples, families to make choices in their lives about how many children they have and so forth. I mean, let's face it, most people like to have sex, and if you are potentially having a child, every time you have sex, because you don't have access to birth control, then you're probably gonna and you're having a lot of sex, then you're gonna have kids. I know that's a oversimplification, probably a gross oversimplification in more ways than one, but it's certainly true. So um, making promoting family planning, especially through education and especially by providing birth control, is something that's really critical. And women of the world really want this too. When I was working in Africa, my female scientists that I worked with, they would bring over uh, uh, birth control pills for some of their women friends in the villages, who were very appreciative and very excited about that. They just didn't have access to that at the time. Anyway, moving on here. Okay, so progress in these three areas is working, and what you're looking at here is a graph of population growth rate. And I've written across the center of this graph to remind you that this is rate, not population size. So this is growth rate over time from 1950 to 2050, projected out to 2050. And you're looking at growth rate in terms of percentage of the population size and the growth. So for example, in roughly around 1963, when this was at peak, the population was growing at roughly about 2.2%. That means out of every 100 people, you would have another 2.2 by the end of the year. That would be representative of that rate. And what you see is that over time, from after peaking in the early 1960s, the growth rate has been going down. We saw this in other graphs earlier. So this is just the same idea, just in a different context and slightly different graph. And all this is good news. And this is the result of what we've just been talking about, which is empowering women and men to make choices and when they have children through family planning, empowering women through education and integration into the economy, and of course, efforts to address poverty and raise standards of living. Those things are paying off. It's working, and we need to keep going with this. People are better off as a result. So I'm going to end with this. It's some more good news. This is a summary of a study that came out just this summer of 2020. I've assigned for you to read an article in USA Today, which gives a pretty straightforward description of the results of the study. What I've got pictured here as a screen capture is an alternate reading you could do if you want. It's optional. It's from Science Daily, and it talks about this study in a little bit more detail. So what is this study? What did it find? Well, some researchers at the University of Washington in the Pacific Northwest, they did a much more detailed model of projecting human population growth through the rest of this century, taking into account some economic factors, women's education, a bunch of other things that were not really built into the United Nations models that are typically used. And the upshot is that their projections are that world population will peak around the year 2064. So that'll be about retirement age for a lot of you guys, 2064. And that peak, importantly, will be around 9.7 billion. And then populations are projected to decline to about 8.8 billion by the end of this century, which is about, as you recall, about 2 billion less than the estimates that I showed you earlier in this video lecture. So all of this is tremendously good news, because that means that this will be fewer strain on resources, which means better standards of living for everyone. Better standards of living equate with so many important things: a better economy for everyone, less strife, less warfare, etc., etc. So all this stuff is tied together. So I wanted to end here with some good news. You have a link to that USA Today article on Moodle for you to read. And with that, we're done for the day, and I'll be seeing you in class soon. Bye. Here's some key messages for you.